Okay, I was asked by some of you to go over the problems that are on the 5th page, or the last page, I guess, of the 5 steps to a 5 capacitor and circuit reading that you did Wednesday or Tuesday night for me. So let's look at this question number 1 really quick. We have a 100 ohm resistor connected in series with a 9-volt battery. I mean, when I say series, all the current goes through that first resistor, and then when the current arrives at this junction, there's a split, and some of the current goes in the 120 ohm resistor, some of the current goes in the 150 ohm resistor, where it rejoins. The first thing I always want to do is figure out the total resistance of the whole circuit so I can calculate the current. We know V equals IR and I equals V over R, so I want to know what the total resistance is. So real quick, the parallel portion, 1 over the total resistance is going to be 1 over R1, in this case 120, plus 1 over R2, 150, and that came out to be, when you reciprocate the sum of the reciprocals, you get 66 and 2/3 ohms. Add that to the 100, and you have a total of 166.66 ohms. Okay, so we can do V equals I equals V over R, and we have a 9-volt source, and divide that by the 166 and 2/3 ohm resistance total, and we end up with a current of 0.054. Okay, so now that you know the current in the total current in the circuit, you can evaluate where there's the most power, because of course brightness, which well, they don't even ask about brightness, they just ask about power. So let's go ahead and do it. Now I'm going to call this R1, I'm going to call this R2, I'm going to call this R3, just for the rest of the discussion. Okay, so power 1, well, because the power can be expressed as voltage times current, or current squared times resistance, I squared R, or V squared over R. And you know, when a resistor has all the current going through it, like resistor 1 does, and you know what that current is, I like using this equation. So P1 is going to equal I squared R, and I squared is 0.054 squared times 100, and that came out 0.29. So for the two that are in parallel, I tend to use V squared over R for parallel, but that means I need to know how much voltage is across the parallel portion. And you'll recall that the voltage across the parallel portion is the total current times the total resistance of the parallel portion. In this case, that's 66.666. So when I calculated the parallel voltage, I got 3.6 volts. So of the 9 volts, 3.6 of it is across these two resistors. Once I know that voltage, then power is pretty easy to calculate. So P2 is going to be V squared over R, and I got 0.108 when I squared 3.6 and divided it by 120. And then when I squared 3.6 and divided by 150 for the third resistor's power, I got 0.0864 watts. So the answer to the question, which one has the greatest power dissipated, would be the 100 ohm resistor, because that's resistor 1 in my naming scheme. The second question here involving a capacitor, I think the trick to this question is just remembering that work and energy are pretty much the same quantity, or equivalent, I should say. You're given that the capacitance of this capacitor is 1 farad, and you're given that the voltage is 12 volts. you can calculate the energy stored when it's fully charged, because U, the energy stored by a capacitor, is 1/2 CV squared. So you can calculate that, and it turns out that that comes out to be 72 joules. So you have that much energy to work with. Now, of course, work is a form of energy. So assuming that all this energy goes into work, and that work is force times distance, now we can do the problem, because it says that the drag force on the car is 2 newtons. Well, that means you have to exert a force of 2 newtons just to overcome the drag force. And so dividing the 72 newtons, joules, by the force of 2 newton, that gives us distance, right? I divided work by force, and that of course comes out 36 meters. And if you do check, that checks out, because a joule is really a newton meter, and of course newtons cancel, leaving meters. So that's why the answer to that one is A. Tried to keep this short and sweet. I'll see you in class tomorrow. Remember, do everything you can to be studying as best you can for the quiz.